All right, let's take a look at the next problem. Here they want us to calculate VO using voltage division, and we're going to assume that R is equal to 7 ohms here. Okay. So let's kind of look at the problem, see what we have going on. So we see that this is the VO that they're talking about, which is implying it's the voltage across this resistor. So the voltage across this resistor actually will have the same voltage as this branch right here, okay? Because they're in parallel. Branches in parallel have the same voltage. But with this, though, we need to combine it down to see how that's going to work, okay? So here, let's combine everything down. We'll see that these two are in series, and notice how everything is in the complex impedance already. So the negative J1, 3, 50 at 10 degrees, all that's already done for us, which is helpful. So let's do series 1. So series 1, we'll do Z series 1 is equal to 5 plus negative J1, which is just 5 minus J1, which we go and calculate that. So 5 squared plus 1 we'll get 5.1 at angle negative 11.31. And these are both in ohms. Just the same way, it's just different ways of representing the same value. Okay. And then the right here, I'll call this ZR. That ZR will be 10, I'll call it ZR1. This will be R2. Okay, so ZR1 will be 10 ohms, which is just 10 at angle 0 ohms. Okay. So once I combine the series down, I can see that these two branches are going to be in parallel with each other. So if I write Z parallel, that will give me ZR times ZS1 over ZR plus ZS1. And I get here, I guess I'll write it out over here. Three R2 R1. Okay. And then I'm just going to draw a block to represent ZS1. Okay. So these two branches are in parallel. All right. So let's go, and we have a multiplication at the top. So let's use the multiplication form that we like to use, which is the phasor. So that's going to be 10 at angle 0 for the resistor. And then it's going to be ZS1 will be 5.1 at angle negative 11.31 degrees. All right, in the bottom we're adding, so we're going to use the rectangular form. So that'll be, so it'll be 10 plus ZS1 we said was 5 minus J1. So when we multiply this out, this will give us 51 in the top, and then negative 11.31 degrees. And in the bottom, we're going to get 15 negative J1. We'll convert that over. So this will be 51 negative 11.31 degrees. Okay. In converting this over, you should be pretty comfortable with it at this point, but be 15 squared plus -1 squared, so square root sum of the squares, and then theta will equal tangent inverse y over x. So when we do that, this will give us 15.03 at an angle of -3.81 degrees. So 15.03 at an angle of -3.81. So we'll have to, since we're dividing here, we'll divide the magnitudes. We'll go ahead and subtract the angles. I just punched that here into the calculator real quick. Yep, okay. And -7.49 degrees. All right. And this will be in ohms, and all that is Z parallel. So Z parallel. So our new circuit is and trust me, I know I'm an artist. You don't have to say anything. R2, and over here I'll call this Z parallel. All right. So now, what I can do is I know that now this branch and this branch are in parallel with each other, so they're going to have the same voltage drop. So I really don't care about this side. What I care about is right here and right there. So if I go and assume that there's a ground down here, I can assume that that point is equal to V. And then I'm going to lose all of it to these two elements here. And that's where my voltage division is going to come into play. So let's check it out. So if I want to find voltage of, I'll call it ZP, yeah, that'll work. Voltage ZP, that'll be equal to ZP over Z total of the branch times V of S, okay? So that'll be Z of P. Z total of the branch is going to be ZR2 plus Z parallel multiplied by the V of S, okay? And like we know that just the ZR2 will just be 7 ohms, or 7 at angle 0 ohms. Just, that's pretty easy. Okay, so let's go and plug those values in. So ZP we had was 3.39 at an angle of negative 7.49. Here, I'll write the converted values. Let me go and plug those in using the same methods as right there. Okay, so for real, 3.36 minus J 0.47. All right. So then now here in the bottom, I'll do 3.36 minus J 0.47. And that should be screwed over just here. Okay. Then we'll add the 7 from ZR2. All right, so when we do this, we will end up getting, I'll leave 3.39. At angle negative 7.49 there. When I combine all these down, I get 10.36 minus 0.47J. Now let me convert it one more time. Okay, so 10.37. An angle negative 2.49 degrees. All right. Now all I'll do is divide the magnitudes and I'll subtract these angles. So 7.49 subtract negative 2.49. So parallel voltage value will be. Oh, and I forgot to include the VVS in there. Okay, we're not done. That's fine. It's fine. So 3.39 divided by 10.37. It was 0.327. Let's give us 9.98 degrees. Again, now let's multiply the voltage source in there, which is 50 at angle 10. Minus negative. Okay, this should be like, what would that be? 0.49 plus 2.49. Minus. There we go. Yeah, there we are. Okay. That makes me feel better. All right, so negative 5 degrees. Okay. Basic math will elude you later on. 50 times 0.327. Okay, so this is giving me 16.35. And then I'll add my angles. I'm sorry. All I did was multiply those two values and then add these two values. Okay. And that'll give me an angle of 5 degrees. So VO is going to be equal to 16.35 and angle 5 degrees volts. Okay. The reason that is because, so right here, we found the voltage from here to there, all right? Which is the same thing as the voltage from here to there, which is the same voltage as here to there. Same voltage as here to there. So all we did was just find that one value and then back our way out of it. And let's check our answer. Looks like we were pretty close. So yeah, a little bit longer, but not that bad. See you in the next video.